Afternoon to all. Today we are going to discuss with the probability. This is our fifth topic. First we will see some basic definitions. Let capital S be the sample space of the random experiment and capital A be the event related to the sample space capital S. Then the ratio of total number of favorable outcomes to the total number of outcomes in the sample space is called probability of A. It is denoted by P of A, and formula is given that P of A is equal to N of A divided by N of S. Important formula for the objective purpose. Variable which is used to denote the numerical value of the outcome of an experiment is called random variable. What is meant by random variable? Random variable means outcome of an experiment. The notation to the outcome of an experiment is called the random variable. There are two types of random variable: discrete random variable and continuous random variable. First we will see discrete random variable. If the random variable capital X takes only a finite or countably infinite values, it's called the discrete random variables. For example, they have given that capital X denotes the result of toss of die, because we know that toss of die outcomes will be, or possible outcomes will be 1 or 2 or 3 or 4 or 5 or 6, only finite in number. That's why this is the example of discrete random variable. Now we are going to look at continuous random variable, or definition of continuous random variable. If capital X takes uncountably infinite values, then X is called a continuous random variable. Here examples are given that weight of person selected at random, or height or room temperature. In the specific range, weight of person means in the specific range all the values are taken by weight, and similarly height of person means if we select the interval from 5 to 6 feet, in that interval each value is taken, because in the across the world there are so many peoples who has heights between 5 and 6, means each and every value between 5 and 6 is taken by that variable, means height, and these are values are uncountable in number, because we know that in the real line, on the real line, how many values between 5 and 6? There are uncountable number values. That's why this is the example of continuous random variable. Now we have to see probability distribution. Suppose capital X denotes outcome of a toss of a die, then X takes values from 1, 2, 3, 4, 5, 6, and each has a probability 1 by 6. We can put this information in the table. Such a table giving the probability of X along with its values is called the probability distribution. What is meant by probability distribution? Information in the tabular form is called the probability distribution. Okay. Similarly, there are two types of probability distribution function: discrete probability distribution function and continuous probability distribution. First we will see discrete probability distribution. In that, what is meant by discrete probability distribution? If the random variable is discrete in that distribution, then this is called the discrete probability distribution. Here example is given that X is equal to 1, 2, 3, 4, 5, 6, and P of X is equal to 1 by 6, 1 by 6, each having a probability is 1. And two important properties of discrete probability distribution are given. First property is probability of all X is greater than or equal to 0, means non-negative, and sum of all the probability is always equal to 1. These two are very important for the objective purpose in exam. Okay, and for the further we have to solve these all the examples by using that properties. So keep in mind these properties. Now second probability distribution is a continuous probability distribution. In the probability distribution, if capital X is continuous, then this probability distribution is continuous probability distribution, and notation for this is f of x, or in simple they have represented f of x in the curly bracket. If f of x is greater than or equal to 0 for all x, this is first property. And second is the integration between minus infinity to infinity f of x dx is equal to 1. It's called the probability density function. Means f of x is probability density function. In short, PDF is also name for this probability density function. Now first see the examples of the discrete probability distribution function. Here first example is probability distribution function of random variable x is 0 except at x is equal to 0 1 2, and they have provided the values at x is equal to 0 1 2. First value at x is equal to 0 is 3c cube, value at x is equal to 1 is 4c minus 10c square, and value at x is equal to 2 means p of 2 is equal to 5c minus 2, and we have to calculate here c and probability of x between 0 to 2. Okay, they have given first given information is written here. P of 0 is given 3c cube, p of 1 is 4c minus 10c square, p of 2 is 5c minus 1. Since here we know that probability distribution function satisfies the total summation of the probability is equal to 1, that's why p of 0 plus p of 1 plus p of 2 is equal to 1. And after calculating we get this is a cubic equation, and we know that cubic equation has three solutions. Here if by solving by using synthetic division method we get three values 1 2 or 1 by 3, but we know that range of p of x is always between 0 and 1. Here c is equal to 1 by 3 is a possible value. Okay, now we are going to study some examples related to the discrete probability distribution function. The question is that verify whether the following functions can be considered as probability density function. Some examples are important for the objective purpose also, because these are the short examples. Okay, first example is given here that p of x is equal to 1 by 5, x is equal to 0 1 2 3 4, and add these values 1 2 3 4 5. They have provided the probabilities are 1 by 5 1 by 5 1 by 5. Okay, and here p of x is greater than or equal to 0 for all x, because here x's are 0 1 2 3 4, and for each x given probability is greater than or equal to 0. That's why first condition is satisfied by this example. And similarly if we calculate sum of all the probabilities we get 1, and this is also satisfied. Okay, means all the two properties is satisfied by this function. That's why given function is following function is probability density function. Similarly we have to calculate other functions are whether they are PDF or not PDF. Okay, second example we will see that here if we substitute x is equal to 1 we get p of x is equal to minus 1 by 8 and 2 is equal to 1 by 4. If we substitute 3 then we get 7 by 8. At x is equal to 1 we have observed that here p of x is minus 1 by 8 means it is a negative value, and we know that p of x is always positive. Here p of x is negative, that's why this is not PDF. Okay, now third one is example is here that f of x is equal to x square plus 1 by 18 at x is equal to 0 1 2 3, x is equal to 0 1 2 3, and probabilities are there. Here we observe that all the probabilities are greater than or equal to 0, and if we add all the probabilities we get total sum is 1. That's why this is a PDF. Now second example, last, p of x is equal to 2x plus 1 by 8 at x is equal to 0 1 2 3. Their probabilities are given, all the probabilities are greater than or equal to 0, and sum of all the probabilities is not equal to 1. That's why this is a not probability distribution function. Okay, here sum is not equal to 1. We have sum is we have required a sum is 1, but here is not 1. That's why this is a not probability distribution function. These are all the examples of discrete probability distribution. Okay, now we are going to study some examples related to the continuous probability distribution function. Okay, verify whether the following functions can be looked upon as a PDF. Here first example is given that 2 by 9 into x into 2 minus x by 2, x between 0 to 2, 3 is given. Okay, this is given information. From that information we have to conclude that range of the integration is 0 to 3. Here we observe that if we substitute all the values between 0 to 3 in that function we get all the f of x greater than or equal to 0, means first condition is satisfied by f of x. Now here from the given information domain is 0 to 3 means range of the integration from 0 to 3, f of x is given. After calculating the integration we know that the integration of x is x square by 2 here, and integration of x square is x cube by 3. After substituting the lower limit and upper limit and calculating we get total is 1, means integration is 1. Total sum or total integration is 1, means all the properties of PDF is satisfied by this function. That's why this is a PDF. Okay, now similarly second example is here given that f of x is equal to half into e raised to minus mod x x between minus infinity to infinity. We know that modulo exponential function is always greater than or equal to 0. That's why first condition is obviously satisfied. Okay, and we have to check second condition only. For the checking of second condition, we have to break that integration or range of integration. Okay, we have to break that range of integration. How to break this? From minus infinity to 0 is one part, and 0 to infinity is the second part. Separately we have to calculate the integration. Okay, and we know that e raised to minus infinity is 0, e raised to infinity is infinity, e raised to 0 is 1. By using the putting all these values here, after calculating we get 1. Both the conditions are satisfied by this function. That's why this is a probability density function. Similarly, third example is find the values of k if each of the following function is probability density functions. They have information given that all these are probability density functions, means they satisfy whatever required conditions for the probability density function. Okay, and our target is finding the value of k. Given that p of x, f of x is equal to kx square 1 minus x square, x between 0 to 1 and 0 for otherwise, given information is this, and f of x is a probability density function. Then by definition we know that integration between 0 to 1 f of x dx is equal to 1, because this is a property of probability density function, and already this function satisfies this PDF. That's why this property having that function. Therefore integration 0 to 1 f of x dx is equal to 1 is taken, and after substituting the values of f of x and calculating separately, we get value of k here. After calculating we know that integration of x square is x cube, x raised to 4 is x raised to 5 by 5, and putting the upper limit lower limit, we get this value of k is 7.5. okay, this is our example. Similarly, second example for finding the k is given here. Range of integration is minus infinity to infinity, because they have provided the interval. Okay, f of x is minus infinity to infinity, k into 1 upon 1 plus x square. Here k is constant, keep it constant outside the integration. We know that integration of 1 upon 1 plus x square is tan inverse x. After putting the lower limit and upper limit, we get tan inverse of infinity minus tan inverse of minus infinity is equal to tan inverse of minus theta is equal to minus tan inverse of theta. That's why here plus is written, pi by 2 plus pi by 2 is pi, k into pi is equal to 1. That's why k is equal to 1 upon pi. Okay, similarly in the third example we have to calculate value of k. For that purpose, this is a PDF. That's why integration value of integration is 1. How to solve this integration? We have to substitute exponent is there. Here exponent is x by 2. X by 2 is equal to t, differentiate x is equal to 2t, differentiating on both sides we get dx is equal to 2t, and after substituting all these values in the integration we get this. Okay, and after solving the some steps, we reach at the step integration 0 to 32k into 0 to infinity e raised to minus t, t raised to 4 plus 1 minus t dt. This is the in the format of the binomial in the format of beta and gamma functions, and directly the formula says that value of that integration is gamma 5. Okay, these are some standard results. From that result, value of this integration is gamma 5, and after calculating, rearranging the terms, we get k is equal to 1 upon 32 into gamma 5. Now fourth one example is find the k if p of f of x is probability density function. F of x is given that k x into 1 minus x, range is between x to 1. Here f of x is equal to k into x minus cube. They have provided large source of examples. See that examples, very important examples, and very simply they have explained. Okay, and now we are going to study binomial distribution. This is our first distribution in this chapter. What are the properties of that distribution is we are going to study now. If an experiment result in only two ways or only two outcomes, having only two outcomes, this is called a binomial distribution, or this is the property of binomial distribution. The probability of success is p, denoted by p, and probability of failure is denoted by q. Such a p plus q is equal to 1. This is very important property. Probability of success plus probability of failure is always 1. Keep in mind, this is important for objective purpose also. The experiment is repeated n times, then the probability of r successes is given by the formula p of x is equal to r, means probability of x at x is equal to r. Probability at x is equal to r is equal to ncr into p raised to r q raised to n minus r. What is mean by n? N times repeated experiment is there, that's why n is taken here. Okay, what is mean by r? R successes are there, p nothing but probability of success, and q is nothing but probability of failure. Means all the symbols are here verified, or parameters are well defined there. Okay, particularly the probability that x will take the values 0, 1, 2 up to r can also be expressed as probability of x is equal to 0. If we replace x is equal to r is equal to 0 in above formula, we get p of x is equal to 0 means nc0 p raised to 0 q raised to n minus 0. That's totally alternately, or ultimately we get q raised to n. And if we replace r is equal to 1, we get probability of x is equal to 1 is equal to nc1 p raised to 1 q raised to n minus 1. A variable having a binomial distribution is called a binomial variable. Means which variable that satisfies the binomial distribution is called the binomial variable. Simple meaning or words suggests the meaning itself. Now, what are the uses of that distribution we are going to study in a problem solving? The tossing of a coin, there are two possibilities, either head or tail. Occur either head or tail. Result of an examination, either success or failure, pass or fail. Result of an game, win or loss. Result of inspection, acceptance or rejection. In all these situation, binomial distribution is used. Okay, in which situation binomial distribution is used, just we have to understand this concept. Okay, and there are some famous properties are here. First property is p plus q is equal to 1, and formula for the mean is given, that is notation for mean is x bar, and formula is n into p. What is mean by n? N is number of outcomes, or that sample size, and p is nothing but probability of success. What is mean by variance? Variance formula is given, that n into p into q. What is mean by n? That number of outcomes or number of sample space are taken. P means probability of success, q means probability of failure, or standard deviation means SD, and notation for the SD is sigma. Okay, symbol similar, that symbol is similar to 6 in Marathi. Okay, this is the symbol is a sigma, and formula is under root n into p into q. Now we are going to study first example. If 10% bolts produced by machine are defective, calculate the probability that out of a sample selected at a random of 10 bolts, not more than one bolt will be defective. Means we have to calculate the probability of not more than one bolt is defective. First, we have to see what is given information. First, understand the problem. Okay. First, write given information. They have provided 10% bolt produced by machines are defectives. That's why P is equal to 10 upon 100, and after calculation we get 0.1. And we know that famous property by the binomial distribution, P plus Q is equal to 1, and from this Q is equal to 1 minus P, and that's 1 minus 0.1 is 0.9, means value of Q is equal to 0.9. Here N is equal to 10 because 10 bolts are selected. Okay, sample is selected, sample of size 10 is selected there, therefore value of N is 10 here. Okay, understand this concept, how to find Q, P and N. Okay, these are very important or basic information is here. Now we have to find probability that not more than one bolt. Not more than means up to 1, means probability at x is equal to 0 plus probability of x is equal to 1. Just we have to calculate these two values. First we will one by one we will calculate this, but first we have to know, or we know that formula is there for probability of x is equal to r, 10 cr, 0.1 raised to r, 0.9 raised to r. 0.1 is the value of p and 0.9 is the value of q. Okay, and then probability of x is equal to 0. If you replace r is equal to 0 in that above formula, and after calculating we get probability of x is equal to 0 at 0.3486. Similarly, if we calculate at x is equal to 1, probability at x is equal to 1, we get 0.3874. If we add together these two values, we get 0.736. Okay, this is the final answer. Probability not more than 1 volt is defective. Now second example is there, from a box containing 100 register, 20 of which are defective, 10 are selected at random. Find the probability that all will be defective. Second target is all are not defective. Third one is at least one is defective. First, from the given information we can calculate n is equal to 10 here, and probability of success is here 20 upon 100, means after calculating we get p is equal to 0.2. Similarly, q is equal to 0.1 minus p is 1 minus 0.2 means 0.8. If x denotes number of defective registers, binomial, we know that binomial distribution p of x is equal to ncx p raised to x q raised to n minus x. Here n is equal to 10. If we replace n is equal to 10 in that formula and values of p and q, we get this formula like 10cx 0.2 raised to x into 0.8 raised to 10 minus x. Now we have to calculate probability that all are defectives, means all the 10 are defectives, means p of 10. Put x is equal to or r is equal to 10 there, means in that formula 10c10 0.2 raised to 10 0.8 raised to 10 minus 10. After calculating we get 1.024 10 raised to minus 7. Now all are not defectives, means 0 defective there, no bulb is defective. Okay, that's why p of 0 equal to 10c 0 0.1 0.2 raised to 0 0.8 raised to 10 minus 0. After calculating all the values we get 0.1073. we know that how to calculate 10c0. This is a combination. Okay, 10 factorial upon 10 minus 0 factorial into 0 factorial, and we know that value of 0 factorial is 1. Okay, understand, these are the previous information और our पुराना ज्ञान टटोले. बचपन सुरक्षित होगा तो याद आएगा तो ठीक है. ओके, नहीं आएगा तो भी चलेगा, लेकिन फॉर्मूला आना चाहिए. एनसीआर का फॉर्मूला यूज़ करना है. एनसीआर का फॉर्मूला कहता है कि एन फैक्टोरियल अपॉन एन माइनस आर फैक्टोरियल इंटू आर फैक्टोरियल. फ्रॉम दैट वी हैव टू कैलकुलेट एनसीआर. ओके, हियर नाउ एट लीस्ट वन इज डिफेक्टिव मीन्स कम से कम एक डिफेक्टिव की प्रोबेबिलिटी निकालनी है हमको. मतलब ज़्यादा से ज़्यादा हम 10 तक लेनी होगी, इसलिए ऑल दी प्रोबेबिलिटी का सम लेना पड़ेगा. p of 1 plus p of 2 plus p of 3 plus p of 10. That's why they have taken p of 1 plus p of 2 plus p of 3 plus p of 10. ओके, और इसके लिए एक और दूसरा फार्मूला है. अगर टोटल में से हम अगर 0 डिफेक्टिव निकाल लेंगे तो एटलीस्ट 1 डिफेक्टिव की प्रोबेबिलिटी मिल जाएगी. दैट्स वाई दे हैव गिवन द फार्मूला 1 minus p of 0. Okay, just calculate the p of 0 and subtract these values from the 1, we get our required result. That's why 1 minus 0.1073, then we get 0.8973. This is our required solution. Now third example is here. In a sampling, the mean number of defective bulbs manufactured by the machine in a sample of 20 is 2. Determine the expected number of sample out of such a 500 samples to contain at least 2 defective bulbs. Given that x bar is equal to n is equal to 20, x bar is equal to, we know that formula for the mean is x bar is equal to np. From that p is equal to 2 upon 20, p is equal to 0.1 there. From the property of the p plus q is equal to 1, q is equal to 1 minus p, q is equal to 1 minus 0.1, and after calculating we get p q is equal to 0.9. If x denotes the number of defective bulbs, then by binomial distribution formula is here, and here n is equal to 20. Put n is equal to 20 there, value of p and q in formula, and probability of x is equal to 0. Okay, we have to, what is the target? First, what is the target? Determine the expected number of samples out of such a 500 samples to contain at least 2 defective bulbs. Once we have to calculate at least 2 defective bulbs, that's why we are finding here p of 0 and p of x is equal to 1. P of x is equal to 0 is 0.01215, and p of x is equal to 1 is 0.270, and after that probability at least two defectives. At least two defectives means total minus two defectives. Okay, at x is equal to 0 and x is equal to 1. If we subtract these two values, addition of these two values from the total means total is 1. Always keep in mind total is always 1, and from that if we subtract these two values we get our required result. Expected number is n into p. Here capital N into p. Here capital N is 500 into our probability is from above 0.6084, and calculating we get 304.2 nearly if expected number is there. Okay, this is our answer. They have provided large number of examples here. Some examples are, we will see these examples in next lecture. Thank you for watching this video. Okay. Pause.